So the 15th Mersenne prime, 386 digit, it reached a peak in 2,556 steps. The next step, it encountered its first special kind of even, but that one has only one more divisibility. So it's an odd even, that was the division, but then it has another division. And then once it encountered that special number, it was able to encounter more. I think only a few steps it encountered a really special kind of even number. It divided it by eight more times. Even to even. So that's the first encounter, which lead to many more encounters. So what I think is really happening is that once it's able to land on that special, it took a long time, 2,556 steps, but once you land on that, the peaks, the new high kind of a pattern breaks, and the digit drops significantly, and it keep even more dropping. This time no new high was formed, because what I think is going on is once you find that special even, it corrects the trajectory, and that 1.5 increment from 3n plus 1 divided by 2, that's a 1.5 increase each time. That was the special increment. I think one can say maybe that's a special increment that helps finding those special even numbers, because when it does find it, it takes a while to find those, but once it finds it, somehow it just makes it much easier to find those special even numbers. So those 1.5 increment, possibly because 1.5 increase each time, and then it becomes 3 times, and then but somehow you only need to encounter one, it corrects itself, and then you encounter another one, and then more, and then there's that loop that's happening. Then it resets it, and then it makes it much easier. Those incremental stairs up helps to find even more special even. So some might say, well, the encounter itself is inevitable because of the 1.5, but could there be a number that will never encounter those? It's always positioned, it's always formed so that it lands in an even, and there are a few even numbers, but in number line, in a set of number line, in a set of numbers, in a range of numbers, there's only a few special even. But the increment itself is just so, I think, is a perfect increment, that you keep multiplying it, it makes it much easier, especially when it's already corrected from one special even to the next. That's what makes it easier to find the next one. And you know what ChatGPT calls as a deep well. So you land on one that will just, you know, pull you down so much that you don't you're no longer reaching new peaks. So that one is halted, and as you keep going down, so as you keep going up, it becomes scarcer, not, you know, because the gap widens in the number line. The even numbers, the gap widens, but you're still able to find it because the number is multiplied 1.5. So once you find it and then it goes down, the gap, the next one would be much closer as the K decreases. But you only need, so you need to find that as the K decreases, you know, the gap sort of becomes much lesser. And so I think you might say, so why does 3n plus 1 works in breaking down? No matter how large the number is, this number is already quite large, 386 digit. Because it could be, I think it's a distribution. It's really finding those distribution of special even numbers. What's the likelihood, given that the increment is 1.5 times? And then once you find one, the trajectory is corrected, so that it's even much more easier. Because when I'm looking at the graphic depiction, it's correct. Once it find one, it has a cascading effect. It's much easier to find the next and that was actually the moment it find one, that was actually the peak already. After that, the digits went down, and then you might say, well, is there a possibility of a loop? You know, just that the having the number, dividing it by 2, constantly pull down the number in much larger magnitude than the 1.5 increase. So you know, so I think that every integer number can find those special events, and once it finds it, that was the trajectory. It really pulls it down, and it's no longer able to move to new heights. That's the theory.